of this lab is to examine the motion of the mass oscillating on the spring, and from the video of the vertically oscillating mass, the students are to track the data in the tracker and using closed group model the actual and expected graph. And the main principles used were the Newton's second law and the energy principle, and the equations used were the kinetic energy, gravitational potential energy, the string potential energy, and the total energy, which is added all here, and I will discuss it further in the coding section. And Newton's second law states that the acceleration of an object is directly related to a net force, and the energy principle states that energy is neither destroyed or created. And this shows the preview from our next slide, or from the glow script. And experiment is that the initial condition was that the spring constant was 6.83, the relaxed length of the spring was 0.123, and the ball mass was meters, and ball mass was 0.402 kilograms, and the system had the ball spring and a gravity because we all put it into as potential energy, which meant the surrounding we put nothing, so there was no external surrounding force affecting the system. And this shows the tracker we plotted the data of the mass oscillating around, and this shows the mass going along the x-axis, and this shows the mass going along the y-axis. And to the code, these are our initial mass, the position, and the velocity of the ball, and the velocity is 0 because it was released from rest, and the gravity is 9.8, and kinetic spring constant and relaxed length of the spring is 0.123. And from here we had to get the kinetic energy, which is 1f mv squared, gravitational potential energy, and we calculated with the ball position of the y, and the spring potential energy, and ks is as we described the spring constant, and s is, we'll see here, is the l, which is the compressed or stressed length with the relaxed length, and the total energy we get by adding all these three variables together, the energies together. And within that t, which is shows the oscillation now, we get the net force by getting the gravitational force and adding the spring force, and then we calculate the velocity and position by using the momentum principle from Newton's second law. And then the spring, we calculate the spring here, and then we calculate the energy changes, first the kinetic energy change, and then the gravitational potential energy, and here spring potential energy change, and then the total energy change. And this is all calculated by doing the current minus the initial, and then this is the result that we get. And you can see that the gravitational potential energy and spring potential energy evens each other out, and then there is no change in energy because of the energy principle. And this shows the oscillation of the ball, and this shows the experiment of what I have plotted in the tracker and the expected model. And you can see there is some discrepancy, which we'll discuss here as the possible error. And I believe that there was a possible error because it wasn't a perfect environment, and because of that, it was just there had to be variables that we couldn't account for, like air resistance and things like that. And then I wasn't able to plot it exactly in the when the ball started moving, so there was also another reason why the initial conditions are not correctly plotted. And so what does it mean? So this means that the energy principle is satisfied. So in my model, the energy principle is satisfied because while it's not a perfect model condition, it maintains the same points in the graph as it oscillates, and it shows that the oscillation is relatively similar, which means that there's no energy loss or created. And the oscillation period was obtained by adding from the peaks, or you can do from the peaks or the lows. I did from the peaks, and then getting the time difference between them, and then getting the average of them. And for both y and x, they were similar. So this just shows that there was no discrepancy, and there was no extra. The model was well created that it stayed constant to what would have been expected for the oscillation period to be. And that's it. Thank you so much.